Sorry, guys. We had couple of seconds, like a minute or two delay. Apology for that. But without uh, diverging the point, I'm going to start it. Like finally, we are close to half of the day, and credit to you entire audience to make it successful. Thank you so much for being with us. When it comes to the automotive cybersecurity, we like how we can forget about software bill of materials and its challenges. We have a speaker who will share his experience and discuss the significance of software bill of materials in enhancing the automotive cybersecurity. Without a delay, let me introduce to you our speaker, David Leichner. David has a 25 years of executive management and consulting experience garnered from leading vendors, including cybersecurity companies such as Cynet, Morphisec, Cybellum. David is also a member of Board of Trustees of Jerusalem College of Technology. In addition, David is a mentor and the guest lecturer to students in MBA program at Hebrew University. David has authored many articles and blogs and has prepared at conferences around the globe on the topic of cybersecurity. Before I hand over to David, please use our Q&A section at the right side to post your questions for speaker, and make sure to visit our lounge areas and booths for networking. One last point to mention, David will be available around 30 minutes after the session. So please visit him in the lounge area, ask whatever questions you have, if not answered during the session. Please welcome David Leichner on the stage. David, stage is yours. I will
Thank you
hand my
very much, Jitendra. I appreciate that. So, guys, I have to warn you about something. I just had an espresso, and I don't know if you're familiar with how they work these espressos, but they usually go from 1 to 10, right, in power and in in strength. So then they started going up 12, 13, 14, 15, and I found a 20. So I'm like literally popping out of my seat on this subject, and we're going to talk about cybersecurity and the driver. Yeah, this is an incredible event, John. This is amazing, Rena. The effort that has gone into this event has been really incredible. And so a call out to John and Rena and all of the people who put this together. Really amazing event. So David Leichner, I'm the CMO at Cybellum, and we're going to talk about cybersecurity in the driver's seat, SBOMs for automobiles. And what we're going to talk about today is we're going to discuss SBOMs, what they are, what you have to think about when you're creating SBOMs. More importantly, what you have to think about when you're managing SBOMs, vulnerability monitoring, P-certs. We're going to then show you a parallel world into another industry and how they've been handling SBOMs. And finally, we'll show you how one company has actually put this into place and have created a CSMS, a cybersecurity management system that handles SBOMs, vulnerability monitoring, and more. So let's jump right in. And oh, I love that Lego car. So a little bit about Cybellum, one slide, and that's it. So a quick intro for those of you who don't know Cybellum. We are a product security company. Our mission is to make the connected products that we all rely on fundamentally secure by creating a whole new standard for product security worldwide. We've been doing this since 2016, and we combine a product security technology with domain expertise, offering a product security platform, managed services, everything ranging from SBOM verification, cyber compliance acceleration, to managed incident response, and much more. So we're really proud to be working with some of the world's leading OEMs, tier ones, tier X's, and device manufacturers. And we're helping also to build a global product security community through our involvement in industry forums and standards activities, and also through our Left to Our Own Devices podcast. This is a podcast that we started, I guess, about a year and a bit ago. And we've had on people who, for example, Alan Friedman, who's the SBOM rock star, I call him, from CISA, from the Cyber Infrastructure Agency in the US government. And we've had on, even our first guest was, I don't know if you're familiar with him, David Colombo, who hacked into 38 Teslas from his little village in Germany. So we have some really interesting guests there. We had Felipe Fernandez from Jaguar, who's in charge of cybersecurity there. And so I really recommend that you get on the podcast and have a listen. So, and you can find that, of course, on our website. And as you can see, we've been working with a lot of the leading OEMs and the standards alliances. So what are we going to talk about today? So product security has literally become the biggest challenge for automotive OEMs and suppliers. I don't have to talk to you about the database on wheels. In fact, we just finished recording right before this session, a podcast with a French supplier of cybersecurity and, or I should say devices and software technology for railways. And we spoke to their head of cybersecurity, and he started talking about the railway database on wheels. And I was thinking, okay, yeah, we have a railway database on tracks, maybe more appropriate. And it's incredible to hear about how many lines of code there are in a railway, in a train. And I always thought, your train, you hook it up on a track with electric and it runs, right? But now it's incredible the number of ECUs that you have in trains. And when you think about, okay, these are trains, but what about vehicles, and the number of ECUs that we have in vehicles, the number of sensors that we have now, it's amazing how much software we have inside. And this has opened up a threat vector, as we all know, which really is causing major difficulties. And one of those major difficulties isn't the fact that we have the hackers coming in, but it's that we have the regulators and the compliance people who are putting regulations in place that we have to abide by. And it definitely is impacting time to market. You get to a point where you're about to go live, you're about to take this vehicle to the market, and you find that, oops, you have a vulnerability. Now, it's interesting. I've been in cybersecurity since 1985, but they didn't call it cybersecurity back then. They called it network operations security or network security. And we were dealing with a lot of fiber optic networks, and we were dealing with the endpoints that were on those networks. And we ran into a lot of issues of people trying to hack in, because I worked for a bank, I worked for a government agency, an aerospace provider. And what's really interesting to see is that, fast forward 30 years later, we're still facing similar but different problems. And these are the challenges that are hitting us in the automotive market. So the challenges that are hitting us, and here, let's look at each part of the design development phase. We talk a lot about shifting left, right? Well, I personally have my own opinion about what shifting left is, and it's not on this slide. So we think about shifting left from right when we're about to go to market into the development phase, and then shifting left again into the design phase. Why? Because you want to catch those vulnerabilities as early as possible. Well, actually, I think, and this is after attending and speaking at the Embedded World Conference in Nuremberg the last 2 years, I've met with a lot of component providers who come from very small companies in Taiwan, in China, in Germany, in the United States, in other parts of the globe, where they have no cybersecurity resources. They have what was coined cybersecurity poverty, right? They do not have the resources in order to generate SBOMs, do vulnerability monitoring. It's a big issue. And when I think of shifting left, I think of we have to shift left, and we have to help these companies. And there are OEMs out there, and there are large industrials out there that are actually helping. So this is actually a shout out to any of you who are listening, who are in some of these bigger companies. You really have to help these smaller companies to come up to speed on how they can check their components and make sure that what they're providing you have been checked for vulnerabilities, that they have been putting out, generating their SBOMs and checking them. So that is, to me, what shifting left is really all about. So let's talk about SBOMs. This is chocolate. I like this chocolate. The problem is that this factory that developed this chocolate, they had to shut down for about half a year. Why? Now, an SBOM is primarily a list of ingredients: sugar, non-fat, and whole dry milk, milk powder, chocolate liqueur, and so on and so forth. Why did they have to shut down? Because there was a vulnerability inside of their chocolate. It's called bacteria. And they didn't know it was there, right? So if you think about it, and I love to use this analogy because I think it's really a good one. If you have an SBOM, an SBOM is providing you with the ingredients of what software you have inside of your components inside of your vehicle, right? If you don't know that there's a vulnerability in there, you get to the point when you're about to go to market and you run into a problem. Or even worse, it gets out to the market, there's a vulnerability comes up like Log4j. We had companies that we were talking to after the fact. They told us, we spent 4 months looking to find where we had those vulnerabilities, in which vehicles, where were they located, how are we going to remediate them? So it's critical to understand that the software bill of materials is simply an ingredient list. What's most important is what you do with that software bill of materials. So the significance of software bill of materials are becoming increasingly important for organizations as they aim to manage and secure the software that they use. And there's really no short answer to the question of what it is, because different components will have different lists of dependencies, of software packages, of version numbers, of authors, of licenses. And now think about this. You get to the point where you're about to take your vehicle to market and you find out that an operating system that you have, it has a vulnerability, right? So what are you going to do? Oh, you're going to change that operating system. Ha ha ha. Yeah, you change the operating system. Then it has to go back into testing. It has to go back into quality assurance. It has to then pass the compliance people and the security people. We're not talking about a simple switch of a version of, some version of Linux or whatever, or some piece of code. We're talking about going back to the beginning of the cycle just for that one piece of code. So it's really, really critical that that you're tracking the software, but you also have to understand the ramifications of what happens if you find the vulnerability. And the earlier you find it, the better. So many organizations, including those in regulated industries, are using SBOMs to ensure compliance with regulations such as WP29, R155, and also to comply with cybersecurity, supply chain cybersecurity regulations. So SBOMs can really be used to assist in identifying and managing vulnerabilities in software, as well as tracking the provenance of those pieces of code within the software. In addition, it can help in management of software licenses, especially if you're using open code. So SBOMs can also be used to track. SBOMs can also be used to track the use of open source software, which is becoming increasingly common, and it can be used basically to support the software development and maintenance within the development cycle. So by providing these detailed information about the components used in the software package, it can assist developers in understanding the dependencies of a software package, which can then help them to identify potential compatibility issues and make informed decisions about the use of new components. And if we think about the management of the SBOMs, well, we have to know, how are we going to create and ingest the SBOMs? How are we going to automate a lot of these processes? How are we going to edit and approve them so you can reliably share them? Because it's not enough just to create the SBOM. It also has to be checked to make sure that what's in the SBOM is actually what's in the system itself. And how do we represent complex multi-component product systems and use those later on for security analysis purposes? So this is something that we have to understand, especially when we're looking at a vehicle, because a vehicle is, you can call it a system of systems, where you have many different components, you have many different ECUs, and all of these come together at the vehicle level. So this is something that companies are working on. And most importantly, you really have to understand, how am I going to create a workflow that enables all the different departments to work together? So we have the development department, we have the compliance, we have quality, we have security, and then on top of that, we have the management layer. And all of them need to be in sync regarding the SBOMs. So let's talk a little bit about best practices for creating and maintaining SBOMs. So first of all, we have to have an accurate list. The SBOM should be the center, of truth, the place where you have that you have the right components inside of that SBOM. Because if you get it wrong, then you're just fooling yourself. If you're doing vulnerability monitoring on a list of components that aren't accurate, you should be able to update these automatically. So when you make changes, it's not enough. If you think about an SBOM, it's really a snapshot. It's a snapshot of the code base of the components that you have inside of your vehicle at one particular moment. And if you make changes to that, you're going to need to update that. Now think about, once you have vehicles out in the market and you're going to make changes OTA, Well, if you're going to make changes that include changes to the code, then each one of those becomes another version. And you need to be able to, if you think about an asset as an SBOM as an asset, you really need to think about, okay, how am I going to manage these assets? How am I going to manage the different versions? And then you have to think of security and compliance, right? So we have the security information, licensing details, and so on. You have to be able to do periodic reviews. And of course, as I mentioned before, all the relevant teams need to be involved so that they're able to understand what those SBOMs are, what the risk levels are within them, any vulnerabilities that you might have. If you have vulnerabilities and you've gone through them, you know, which ones are important, which ones are less critical, and so on. So when we think about SBOMs, we also think about the different formats and standards, right? So basically, I've decided I'm going to drill down today on 3 of those. And what I'd like to do is to share with you the work that was done in the NTIA Software Transparency Group, where they found that 3 main formats are commonly being used. Those are Cyclone DX, SPDX, and SWID tags. And I'd like to go into each one of them. So let's start with the SPDX format. So the SPDX format, it's a specification, which is an ISO IEC standard for sharing information about software components, licenses, copyrights, and security details in multiple file formats. This project was it's developed and continues to improve a set of data exchange standards that allows businesses and organizations to share metadata in a format that can be understood also by humans, also by machines, simplifying the software supply chain process. And the SPDX information can be linked to specific software products, components or sets of components, individual files, or even small code snippets. It's focused on creating and refining a language to really describe the data that can be exchanged as part of the SBOM, and the ability to present the data in multiple file formats like RDF, XML, XLSX, tag values, JSON, and so on, and to make it easy to collect and share information about the software packages and related content, which definitely helps in the accuracy of the SBOMs. So the SPDX specification outlines the fields and sections necessary for a valid document. It can effectively capture software bill of materials data by representing the components found in software development and deployment. And it's used to document things like distro, ISO images, containers, software packages, binary files, source files, patches, and even small code snippets that are embedded in other files. So SPDX, it offers a comprehensive set of relationships to connect software elements within documents and across SBOM documents. And it can also reference external sources such as the National Vulnerability Database and other packaging system metadata. So this is SPDX. Cyclone DX, which from what I've seen in my experience, is actually a standard that's being used even more than SPDX. It was established back in 2017. Basically with the aim of fully automating security-focused SBOMs. So the core working group, they release updates on a regular basis. And in fact, Cyclone DX, the latest update, I believe, was just recently put out about 3 months ago. And there, again, the SBOMs can be represented in different formats like XML, JSON, and protocol buffers. So if we think about what is Cyclone DX, it's pretty much of a comprehensive SBOM standard that can categorize various types of software, including applications, components, services, firmware, and devices. And it's widely used across industries to describe software packages, libraries, frameworks, applications, and container images. And this project is compatible with major development ecosystems and offers implementations for software factories like GitHub, and it also enables to fully automate the SBOM creation. So if we think about Cyclone DX, it's intended for use in supply chain component analysis and software security. And by the way, we had Steve Springent, who's one of the early, you can call them one of the early fathers of Cyclone DX. He was on our podcast, Left Your Own Devices. And if you go to cybersecurity.com and you go to the resources section, you can see the podcast, and you can go back and listen to what Steve had to say about Cyclone DX. It's a very interesting discussion. So it's an open sourced standard that was developed by OWASP, the Open Web Application Security Project. So maybe just one more word on Cyclone DX. It's pretty much a list of open source and proprietary tools that support standards which are very much in line with what's happening now in the industry with SBOMs. Its specs lay out a detailed object model that ensures consistency, and it can be validated with XML schema, with JSON schemas, or by using the Cyclone DX command line interface. And media types for XML and JSON are also provided for automated delivery and consumption of these supported formats. And we've been also working with Cyclone DX, and most of the companies that we work with are using Cyclone DX. So last on the list here are the SWIG tags. So SWIG tags were created to enable organizations to track software installed. You think of a SWIG tag. So why is it called a software identification tag? Because there's a tag that's put onto the software in order to track it. And this was a standard that was established back in 2012, I believe, and it's been revised a few times since then. And these tags contain detailed information about the software and the specific release of the software product. So the SWIG standard outlines a way of tracking software. It's added to an endpoint. So if you're putting this into a component, it will be inside of that component in order that it can be installed in the software product. And of course, if that component is taken out, it gets removed. So the existence of this software tag, it means that the developers can go back and do a search for this tag in the event that there's an issue or a vulnerability, and they can then track the tag. It's similar to the way we track clothing, I guess, if we have a tag on the clothing inside of a store, RFID, and this is SWID. So we track the life cycle of a software component, and there are 4 basic tags in SWID. So there's the primary tag, the patch tag, the corpus, and the supplemental. Corpus, primary, and patch tags, they serve similar purposes in that they describe the existence and the presence of different types of software, the installers, the software installation, software patches, and also the possible states of software products. On the other hand, supplemental tags, they provide additional details. That's why they're called supplemental. And they supply supplemental details that aren't found in the corpus primary or patch tags. And what they're providing is extra metadata that may be useful. And together with the other tags, they perform a variety of functions such as, I mentioned it previously, software discovery, configuration management, and vulnerability management. So SWID tags, they also can function as an SBOM, as they are supplying information for a software component, just, of course, making sure, as we discussed previously, that it has to be checked to make sure that everything in that SWID tag is what's inside of the software. Excuse me. So the tags link to other tags, and then you can also build dependency trees, and they can be generated during the build and packaging processes, enabling the automatic creation of SWID tag-based SBOMs when the corresponding software packages are put together. So Cyclone DX, SPDX, and SWID tags. So let's look at what are the minimum required elements for SBOMs. And this is something that also is detailed in the compliance and regulations and guidelines. So we have data fields. An SBOM has to have data about the software components, such as the component name, the supplier name, versions, unique identifiers. It should also include information about dependencies. We also need to have practices and processes. So the SBOM documentation should also outline the standard practices and procedures for creating and updating the SBOM, and that's in order that the SBOM can then be added to or that any kind of updates that are done can be put in to the SBOM where it should be put in, and for distributing, accessing, as well as handling errors. And finally, automation support. So the SBOM should be able to be both machine readable and also it should be readable by humans, as we talked about earlier, and it's typically in the standards that we mentioned. So let's talk about some of the challenges associated with obtaining an SBOM. Now, we talked in the very beginning about shifting all the way left, right? So one of the big issues that companies have, and by the way, this is a picture here of Embedded World in Nuremberg, where it's very different. There isn't so much cybersecurity happening there, which I think will change in the future. But this is an event that is geared towards the embedded systems that are being developed, the components being developed for automotive industry, medical device industry, and others. And so what we see here is intellectual property is number one. You have a little company, they're developing components, they don't want to give away the intellectual property, and they feel that if they're creating SBOMs, then they're giving away intellectual property. Second, you have SBOM standards. These are quite often, SBOMs are being developed in different standards, and those standards don't always talk to each other. Third, supplier resources, cybersecurity poverty. They don't have the resources in place in order to provide, whether it's, they might be able to create an SBOM. That's the easy bit, but they can't manage them. They don't have asset management for them. They don't do vulnerability monitoring. And they also don't have the ability to track the different compliance and regulatory guidelines of the changing requirements. So those are the issues. Now, when we look at what are the different tools for creating and managing SBOMs, there are many out there. And we have the SEA tools, software composition analysis tools that are used to analyze software components. We have DevOps and CI/CD integrations that directly plug into the development pipeline to create to automatically create the SBOMs as part of the development cycle. We have container image analysis tools. We have asset and vulnerability management tools for actually storing the SBOMs and doing vulnerability management on these SBOMs. We have ID and source code scanning tools. We have binary scanning tools. There are so many different tools out there for creating the SBOMs. We are more limited on the side of managing the SBOMs. You might be able to manage them as assets, but it's lacking in the workflows. It's lacking in the workflows to be able to streamline the teamwork across the different departments in the company, and also with ensuring ongoing vulnerability monitoring. This is probably one of the most important pieces to the puzzle, is to be able to actually understand the risk. Because again, if we have the chocolate bar and we don't know that there's bacteria inside of that chocolate bar, the factory will end up being shut down for 6 months, as was the case in the example I gave you at the beginning. So you have to understand what your risk is. You have to mitigate the risk. We have to be able to come up with a long list of vulnerabilities. And then the secret sauce, you have to find a solution that can triage that down into a workable list of vulnerabilities so that you can actually spend your time dealing with the critical vulnerabilities instead of trying to work your way through thousands of potential vulnerabilities that actually have no influence on your product development or getting your product to market. So I want to give you just an example from the medical device security area, where SBOMs has become a huge issue. And in fact, there was a bill that came out, an appropriations bill that came out this past December called the Omnibus Bill. And in there, it specifically talked about 4 different pieces. Okay, it talked about the fact that you need to provide, here in the upper right-hand corner, you need to provide an SBOM with OSS, commercial and off-the-shelf components. You need to be able to check the critical vulnerabilities that cause uncontrolled risk. And you need to be able to track post-market cyber vulnerabilities. So we have some of this already in the automotive industry within the WP29 regulations and R155, right? So, and this is another piece, and this is interesting. You have to be able to comply with future requirements that demonstrate cybersecurity. That's an interesting one. So the United States government said, we don't know yet what those future requirements will be, but you have to be able to comply with them. So yeah, we'll see what that means. So it's actually becoming one of the biggest hurdles. It's actually becoming one of the biggest hurdles for getting medical devices to market. And in fact, the FDA, Federal Drug Administration in the United States, came out at the end of March, and they said that there is now a refuse to accept order in place that if the companies do not show that they are able to abide by the cybersecurity regulations, then we have the right to refuse to accept the submissions of these medical devices for approval by the FDA. And they said, but what we'll do is we'll help you to get through these hurdles until the beginning of October. So actually, the medical device market is going to go through a metamorphosis of cybersecurity regulation handling. Beginning of October, the FDA then will be able to say, we refuse to accept this submission. So it's quite an interesting time for that market. So if we think about what are the valuable insights that we've learned from the medical device market that we can bring into the world of automotive. So just like in the medical device industry, safety is paramount for the automotive sector. Successful SBOM implementations in medical devices emphasize compliance with regulations, also for functional safety and also for cybersecurity. And that's the same as we have inside of the automotive industry. You have to have collaboration across the ecosystems within the company, the development teams, the compliance teams, and so on, as we discussed. Supply chain transparency, left, early integration and design, regulatory alignment. So a lot of these things we're seeing in the automotive industry, and vehicles are software, are databases on wheels. They also have the fact that we're moving into autonomous vehicles is taking an already understood threat vector and making it much greater. And the hackers will be trying to get in, and all of the different components within the vehicle are basically linked to ECUs, linked to the internet. So in fact, I spoke to I was at IAA, the big automotive show in Munich a couple of weeks ago. And I spoke to someone who said, well, we're developing, they're actually developing intelligent lighting inside of the company, inside of the vehicle. And I said, okay, so you've got cyber issues also. They said, no, not really. We're not connected to anything but the ECUs. The ECUs, those are connected. I told him. He said, okay, you should talk to my cybersecurity guy. It was actually the CEO of the company. All right, so just moving along, because I want to leave time for a Q&A. So here's some information about LGVS, which is a very large tier 1, and how they implemented a CSMS. Basically, they wanted to, and I guess I don't have to, but explain who LGVS is, but they're a solutions company that's providing solutions to many of the OEMs. They also work in conjunction with the ZKW group and with Magna on the powertrain. Their key goals were cybersecurity compliance. Number one, as many of us are in that situation, that the regulators are our first goal, because we have to get past them in order to get to market, to enhance product security with multiple use cases, and we'll talk about those in a minute, and a unified security approach. That means that the management wants to be able to see what's going on, and also all the various departments. They need to be scalable. They need to be able to grow their product in complexity, because their product is complex and it's just growing in complexity. And of course, they want to be able to get their products to market, and they need to have the overall management. So they implemented a product security platform. This provided seamless integration to Codebeamer, Jenkins, and Jira. They are able to put into place system of system models. We talked about system of systems being all of the different components and ECUs and sensors inside of the vehicle coming together as one master system, where you can actually have a look and a drill down from one level into all of the different components. They've automated SBOM generation, vulnerability assessments, exploit analysis, and their own security policies are validated using the platform's policy engine. So you can see here they've really put into place a comprehensive CSMS that allows them to generate, manage SBOMs, vulnerability monitoring, and to be able to also provide the post-market support that is needed in the event a vulnerability is discovered. And this is kind of what it looks like. There's Security Management Center, cyber compliance, the vulnerability side, the incident response, software licensing, and at the base is the SBOM management and the ability to create the SBOMs and to manage those across workflows across the entire organization. So what they were able to achieve, first of all, most importantly, WP29 vehicle type approval. It's much quicker and more streamlined. And they were also able to automate SBOMs, the creation, the management, and probably most importantly, they were able to triage. 50% of vulnerabilities are automatically triaged by the platform, saving days, hours, months sometimes of work by the analyst, and more importantly, allowing them to focus in on the critical vulnerabilities that they have inside of that they potentially have inside of their components. And just quoting from Sung-Ho Wang, the cybersecurity analyst team leader, implementing a product security platform into our product security efforts has helped our teams produce a comprehensive CSMS. They were the first automotive component supplier to receive certification from TÜV. And that says a lot about how, if you pull all of these pieces together, you will be able to receive that compliance. And lastly, before we go to Q&A, I want to just, we lived through Log4j. We saw the impact that it had. So I can't emphasize enough how critical it is to have incident response in place. Incident response that can pinpoint the affected vehicles, that can help the analyst to uncover where they are, how we get to them, how we remediate the vulnerabilities as a basis to facilitate the entire investigation. So this is something that if you don't have a plan in place, and even if you have a plan in place, go back to that plan and say to yourself, okay, if I get hit tomorrow by a vulnerability inside my vehicles that are already out in the market or have already been shipped before they get out into the market, how am I going to find them? How am I going to get to them? How am I going to remediate that software? And hand on heart, you make sure that that plan is up to date in order to be able to take care of the incident response that you need. So at this point, I'd like to open up for any questions that you might have.
Thank you so much, David. And I believe we might not be able to take all the questions, but one highest voted questions, we will take it. Besides known vulnerabilities, what do you think about adding information about internally found vulnerabilities like those from static or dynamic analytical tools or from penetration tests? Have you ever come across such a use case?
Yes. So when we think about vulnerabilities, I can tell you the way we handle it inside of Cybeom. We work with also publicly available vulnerability databases, but we also work with our own database that we've built up over the years of the experience that we have, also from vulnerabilities that we've discovered from our own analysts that have been published subsequently as CVEs. Also, vulnerabilities that have been discovered by, at our customer sites, and whether it's vulnerabilities that come out of SaaS tools or from penetration testing, these should be then included in the, let's say, the vulnerability database. Maybe that's not externally available, but that is within your own organization to be included, to be tested against the SBOMs. And really important is share it with the community. So if you come up with a vulnerability, if you're working with SCAR or with AutoISAC, share this information with the community. One of the main reasons we have this Secure Our Streets conference, one of the main reasons that John and Rena have worked so hard and ASRG and to put this together is because this is for sharing information. This is for sharing ideas, for brainstorming. More importantly, is to share those vulnerabilities.
That's a great point, David. So one more question, I will take it, is about, can you share some thoughts on potential impact of SBOMs on insurance policies and premiums in the automotive industry, particularly in the context of cybersecurity?
Sure. So I think we have to look at two different types of insurance. There's cybersecurity insurance that maybe an OEM would take out, and then there's the insurance policy that a person would take out. So now that we're at the point of regulations where SBOMs are necessary in order to get certification, I think that on the OEM side, the insurance policies will be there. But if they can show you know, a lot of what's involved in insurance is showing that you actually have the procedures in place and the policies in place. There is nothing that's 100%, but you have to be able to show that, yes, we have SBOMs in place. We track those SBOMs. We do vulnerability monitoring. We have a PCERT in place. And if you can do that, then more times than none, your insurance, let's say, risk will go down substantially. As for the person who's buying the vehicle, I don't know if it's going to get that far. That would be interesting. I could definitely see the dealerships using cybersecurity protection as a selling point in order to get people to buy their vehicles. Whether or not the actual insurers at the consumer level will take that on, I'm not sure.
Thank you so much, David. I believe we are almost close to time, but no worries. All David is very generous, and he's said he will be available for next 30 more minutes in a lounge area. So please feel free to reach out and ask all the questions you have it in the launch area once you connect with David. And I believe, David, thank you so much. The kind of energy which you have mentioned initially, you exceeding that, and we are also feeling like a lot more. The information we are receiving, it highest energy we are gaining from you as well. So we appreciate a lot, and thank you so much for your experience and the knowledge shared, and provided the guidance in terms of the SBOMs. And thank you. And everyone, please visit our launch and booth for networking and connecting and knowing about the more products and getting your questions answered.
And
Thank
come
you.
visit our team in the Cybersecurity booth.
Yeah, great point. Thank you, David, for mentioning that. And please feel free to reach out. Have a good time. Bye bye.